Good morning, everybody. Today's topic is WPS Wi-Fi protected setup. Contents are like this. First of all, we will go through the introduction part. What is WPS? Why it came into picture like this. Then how a WPS GUI looks like. Where do I find WPS stuff on my router? Then the different types of modes it's supporting. Technical architecture, different types of interfaces, registration protocol, what is the behind it, sniffer logs, how you will come to know as a technical guy, how you will look to the sniffer logs, how you will come to know all the stuffs regarding WPS. Then the WPS connection sequence diagram part, and the finally references. Let's start with introduction part. This WPS stands for Wi-Fi protected setup. So, as the name suggests, this is a setup which is protected. In the earlier days, it was known as WSC. That is nothing but Wi-Fi simple config. WPS is nothing but network security standard that attempts to allow easy establishment of a secure wireless home network. This feature is activated by default on almost all the WPS supporting devices. This was created by Wi-Fi Alliance and it got introduced in the year 2006. The main motive of this protocol is to allow the home users who know little of wireless security, as well as making it easy to add new devices to an existing network without entering long passphrases. What they are trying to say is, suppose I am not well acquainted with the technical things, how to connect, how to enter the passphrase, all these steps. So for that kind of peoples, this feature came into picture. If you're a technical guy, then if you open the GUI of a particular AP which supports WPS feature, it looks like this. This snapshot I took from TP-Link AP, and when you will go to the advanced page of the AP, you can see the options like routers, PIN, WPS wizard, push method, PIN method. They are the things you are going to see. We will further discuss what are these things, how they came into picture, what the role of these things, all stuff. See, when you look into a router where you can find the WPS part, whether it's supporting WPS or not, how you will come to know. First of all, looking by the outer cover. So these are the symbols where the red arrow mark is there. You can see that. You're able to see, right? Yeah, these are the things. So the WPS part. Here it's written already that WPS. Okay. So from that point of time, you will come to know that this particular router is supporting our WPS feature. Then coming to the different modes it's supporting, this WPS emphasizes usability and security. They are the basic two purposes of this WPS. Basically, it allows 4 modes for adding a new device to the network. And as you see, they are broadly classified into 2 categories. First one is in band, the second one is out of band. Under in-band category, there are two methods again coming, PIN and PBC. Similarly, under out-of-band, two methods are coming, NFC and USB. So let's go one by one. PIN method. A PIN has to be read from either a sticker or display on the new wireless device. If you look into an AP, there will be a sticker and on that WPS PIN should be mentioned. And this PIN has to be entered at the access point. So this is the method which is mandatory baseline mode. Got it? Yeah. Coming to the second method, that is push button connection method. In short, we can say that PBC. So here what user has to do, just he has to push a button, either an actual one or a virtual one, on both access point and new wireless client device. On most of the devices, this discovery mode turns itself off as soon as a connection is established, or after a delay of 2 minutes. This is an inbuilt feature. Okay, this is how it's designed. So out of this, whichever comes first, it behaves accordingly. So the reason it's doing like that is it's thereby minimizing its vulnerability. Okay. This PBC mode is also mandatory for access points, and they are the optional for connecting devices. Coming to the third method, that is NFC, near field communications method. In this method, what happens, user has to bring the new client close to the access point to allow a near field communication between the devices. This is optional feature. Okay, USB method. So in this method, the user uses a USB flash drive to transfer the data between the new client device and network's access point. This mode is also optional but deprecated as of now. Next is technical architecture. This WPS protocol defines 3 types of devices in a network. First is enrollee, second is registrar, third one is AP. So what do you mean by an enrollee? A new device that needs to be added to the network and does not have settings for the wireless network. I mean to say that there is an AP. I'm a client. You think that I'm having a laptop. I don't have the wireless settings with me. So I won't join with the network. That's one called the enrollee. Next part is registrar. Registrar which provides wireless settings to the enrollee. That device is called the registrar. So broadly, registrars are classified into 2 categories. First one is internal register, the second one is external register. Internal registers are integrated into a wireless access point. The AP itself behaves as an internal register. Okay. Second one is when it's provided as a separate device, that time we call it as an external register. Third one is AP. AP is nothing but which provides normal wireless network hosting and acts as a proxy between the register and an enrollee. This is the diagram. This is the register. This is the enrollee. This is the AP. So basically, if you look at this picture, you will come to know that there are three different types of interfaces. First one is marked as E. E interface exists between enrollee and register. M interface exists between register and AP. And the third interface, which is nothing but A, exists between enrollee and AP. Let's go into detail of that one, interfaces. Interface E is logically located between the enrollee and the register, as we saw in the previous slide. The purpose of interface E is to enable the register to discover and issue WLAN credentials to the enrollee. It's very easy to understand, right? Yeah. Coming to the second interface M, this exists between the AP and the register. Its purpose is to enable an external register to manage a WPS AP. So this comes into picture when the register is external. Third point, the interface A. This exists between the enrollee and the AP. The function of interface A is to enable discovery of the WPS WLAN and to enable communication between the enrollee and IP only registers. Well, next slide. What are the protocols working behind it? They are called registration protocols. The registration protocol is defined and detailed in the Wi-Fi protected set of specification. It establishes the roles of each device, AP, register, enrollee, etc. It securely conveys WLAN settings and other configuration from the register to the enrollee. This is the second task. Third one, it establishes an extended master session key that is called EMSK, which can be used to secure additional application specific configuration functions. Connection establishment of a WPA to network in WPS consists of the following steps. So here what I am trying to tell you is AP is configured into WPA2 security and WPS is enabled. In that case, how the things are going to happen, I will explain you now. So basically here you can see some 5 steps are happening. First, the authentication and association, that you can say the round 1. Second is WPS if procedure. Okay. In this, what will happen? If will start, identity, request, response, all these frames will get exchanged. That is nothing but the WPS registration procedure. M1 to M8 message will get exchanged. Then if will done, and it will end with an if failure message, as this is not the real network authentication. Okay. After the if procedure, deauthentication will happen. I will explain you what is the need of deauthentication, all the stuff. Okay. Then the authentication and association for the round 2 will happen, that is round 2 you can say. And the finally 4-way handshake will happen, that is ePort 4-way handshake, because we configured the AP in WPA2. Okay. If you will configure the AP in open security, okay, then this authentication and association will happen, then WPS if procedure, then deauthentication, then once again authentication and association will happen. Okay. Then how can you analyze the sniffer logs this is just an overview. Okay, see, first of all, how you will come to know that as a technical guy WPS is enabled in AP or not. Just you go to the sniffer logs, you capture the sniffer logs, look into the beacons. If WPS is enabled, then that beacon frame contains an IE called WPS. Element ID is 221. If WPS is not enabled, the beacon frame does not contain WPS IE. This is the first thing. You will come to know that WPS is enabled, the AP which I am going to connect with. Then the EAP message frame. The way I explained you in the previous slide, EAP procedure will happen. So in that, WPS IE contains all the details of the WPS methods which you are using, either PIN method or PVC method. Normally in the APs, PIN and PVC method only you can find. If I know correctly, NFC and USB also deprecate. Both the methods are deprecated. Okay. Then also this WPS IE contains details of current packet type. Which packet type you are going to exchange, M1 to M8. So this all are a part of EAP message exchange part. Okay. So after the first round of authentication and association, then EAP message exchange will happen. Then deauthentication happens. You know what is the reason behind it? The reason is this is not an real-time authentication procedure, as we saw in my previous slide. See, this is not a real network authentication. So for that, what happens? After the EAP message exchange, deauthentication happens. The reason is, from that process, PSK is going to generate, which can be used in the second order association process. Like for WPA2, this is required. Okay, that's the reason if failure happens. Coming to WPS connection sequence diagram. Here it's clearly mentioned that, see, there is a station that is nothing but enrollee. There is an AP that is called register. So first of all, AP is doing beaconing. Then the probe request, probe response will come. Then the authentication request, authentication response will happen. Then association request, association response will happen. So this is nothing but the round one authentication association. Then this all our EAP procedure happens. As I showed you in my previous slides, EAP procedure consists of 8 packet types, M1 to M8. So these are the M1 to M8. Here you can see clearly M1 to M8 messages. Finally, when enrollee will say that WSC done, then the if failure will happen. Then the deauthentication. Again the authentication and association, then the ePOL key exchange will happen and the connection will be established. So this is the whole things I explained you. I hope this will be helpful for you to understand how the things are happening in WPS, what are the methods, like what are the types, what are the underlying protocol behind that, what are the message exchanges happening, what kind of message is happening, how you will look into sniffer as a technical guy, and finally the sequence diagrams. And there are the references. I took the concepts, so you can go through these things. This will be from this you can get all the information also. Okay, so finally, if this video is anyway helpful for you, please like, subscribe, don't forget to comment it and share with your friends. Thanks a lot, guys. See you in my next video. Bye bye.